Grade 9, Subject Physics, Chapter Force and Laws of Motion, Module 2. Objectives. At the end of this module, you will be able to define momentum, identify the unit of momentum, solve problems related to momentum. Momentum. In order to understand Newton's second law of motion, we should first know the meaning of the term momentum of a moving body. We know that a cricket ball is much more heavier than a tennis ball. Suppose we throw a cricket ball and a tennis ball, both with the same speed or velocity. It will be found that more force is required to stop the cricket ball and less force is required to stop the tennis ball. This is because, due to its greater mass, a moving cricket ball has more momentum. Because of its large momentum, a fast moving cricket ball can sometimes cause injuries to a cricketer, but a moving tennis ball cannot do so to a tennis player. So, what is momentum? Momentum. The force required to stop a moving body is directly proportional to its mass. And the force required to stop a moving body is also directly proportional to its velocity. Thus, the quantity of motion in a body depends upon the mass and velocity of the body. This gives us another term known as momentum. The momentum of a body is defined as the product of its mass and velocity. Momentum is equal to mass into velocity, or P is equal to mv, where P is the momentum, m is equal to mass of the body, v is the velocity of the body. So, if a body is at rest, its velocity is 0 and hence its momentum is also 0. Momentum is a vector quantity and takes place in the direction of velocity. The SI unit of momentum is kilogram meter per second. Every moving body possesses momentum. Since momentum depends on the mass and velocity of a body, so a body will have a larger momentum if its mass is large, or if its velocity is large, or if both its mass and velocity are large. A karate player can break a pile of tiles or a slab of ice with a single blow of his hand. This is because a karate player strikes the pile of tiles or slab of ice with his hand very fast. In doing so, the large momentum of the fast moving hand is reduced to 0 in a very short time. This exerts a very large force on the pile of tiles or the ice slab, which is sufficient to break them apart. Now, let us have a numerical problem. What is the momentum of a man of mass 75 kg when he walks with a uniform velocity of 2 meters per second? We know that momentum is equal to mass into velocity. Mass m is equal to 75 kg. Velocity v is equal to 2 meters per second. Putting these values in the above formula, we get momentum is equal to 75 into 2 kg meter per second. That is 150 kg meter per second. In this module, you have learned that Momentum is a product of mass and velocity. The unit of momentum is kilogram meter per second. Momentum is equal to mass into velocity.